take this number on the right, or maybe you didn't see it in class, and this number on the left, and you're supposed to write all the factors of 8. So I'll do that for you right here. It's plus or minus, well, let me do it differently. 1, 2, 4, and 8 are all the factors of 8. And then the factors of 1 on the left are just 1. So there's this thing called the rational root theorem, where you take each of the numbers on the top, divide by the numbers on the bottom, and those are your possibilities. So your possible x's, we'll say it this way, possible x's are plus or minus 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4, and 8 divided by 1 is 8. So there are 8 possible numbers that could work here. And you're supposed to try and find them through guessing. And you did not see this in class, or you did?
So kind of. So what we did, or what he taught us, is you take all the factors of 8 like you did, but then to find like the possible x's, he taught us a way in our calculator, but I don't know. So I kind of like how you did it. How did you do it again? You just divided.
You divide each of the factors in the top by the bottom.
Yeah. So I just think that's much easier, and you just try and figure out which one works.
Right. Now, for our lesson today, I'm going to give you the one that works, give you the ones that work. So what I do, and if you're allowed to use a calculator, this is nice. You actually graph it to start, and then that helps you to figure it out. On a test, though, you normally aren't given that. So after looking this over here, I can tell you that, for example, that, and you might have guessed this, like 1 works. Okay, so you're going to use synthetic division for all these problems. And if to do synthetic division, you need the coefficients of the x terms, like this.
Yeah.
Okay, and because this works, we're expected to get 0 at the end here.
Yeah.
Okay, so you bring the 1 down, and then you take the 1 down here on the bottom, and you multiply it by the 1 inside there. That's 1. Put the result under the -6, and then you're always adding vertically. -6 plus 1 is -5. 1 times -5 is -5. 2 times 1 is 2. 6 plus 2 is 8. 8 times the 1 in the box is also 8, and that gives you 0.
Yeah.
So we know that 1 is a factor. So because 1 is a factor, well, I'm sorry, that's not correct. 1 is a 0. And I guess we just need the zeros or the solutions, but sometimes you have to write it in factored form when you're all done.
Yeah, so for ours, it has us write the zeros, and then it also has us write out the factors.
Yes, so you may want to do that as you go here. Now, because I'm giving you the ones that work here, okay, so I don't want to say this. You would actually try the number again if it works, because there could be a double root. How often does it happen? I don't know. It depends on the problem. That's why it's so important to know whether you're going to have the graph or not, because you can essentially be guessing blindly. This one does not have a double root, so you don't check 1 again. But that would normally be the approach. Like if you didn't have a calculator, if you're doing this 100 years ago, you would just try 1 again, and maybe it works, maybe it didn't.
Yeah.
Okay, so 2 does work. So we bring the 1 down. 1 times 2 is 2. Add, you get -3. -3 times 2 is -6. You add -4. -4 times 2 is -8. And then you get a 0 here at the end. So we know that 2 is a 0 / solution x minus 2, like that. And now, because you've reduced it twice, so each time you get a number that works, it reduces the degree of the polynomial. So you start out with an x to the 4th. So this line next to the 2 is a cubic, and then this line down here is a quadratic, and it corresponds to x squared minus 3x minus 4. And the reason is because The reason you do this is because you know how to solve every quadratic. You can always solve a quadratic. You don't keep using synthetic division. Use it for the first couple, but then from here you would try like factoring.
Yeah.
Can you try factoring this for us, please?
So it'd be x minus 4 and then x plus 1.
Yes. Now you got to be careful here. Like, so are we factoring or are we giving the zeros? So there's kind of two answers here that we're going. This leads to that 4 is a 0,
Mhm.
and then -1 is also a 0. Actually, we can put that.
Yeah.
So there's like two answers. You're like, here's the factored form, and then x minus 1 from the earlier, and then you also have to say, okay, 4, -1, 2, and 1 are zeros or solutions.
Yeah.
And the reason we're doing it this way is because on a test or a quiz, you will have to do the synthetic division
Yeah.
for that. Have you seen synthetic division in class?
Yeah. That's how
Okay.
we've been doing it.
Yeah. Okay. Let's look at number 11. All right. So again, like you take that last term, and then if there is a coefficient on the first term, you would grab that, but you write the factors of 12 over the factors of whatever's in front. So 12 is 1, 2, 3, 6, and 12. And there's always an even, no, there's not always an even. They're always sort of paired up. So I did miss one here. There's 4. They're paired up. So like 3 goes with 4, 2 goes with 6, 1 goes with 12. And then on the bottom here, it's just 1. And it's always plus or minus. So these are sometimes you get a question on a quiz or test, which is like, write the possible ones. So plus or
Mhm.
minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And that's a lot. I mean, that's a lot to have to guess. And
Mhm.
that's where I always tell students, like, raise your hand and ask, like, find out, like, am I going to really have to guess these, or will I, be able to go to my calculator and at least figure out, a couple that work, even though I'm going to show my, even though you're going to show your work here with synthetic division, but yeah. So let's try, well, actually, let's write the coefficients. So 1, -9, -4, and 12. And then we're going to try -2. Okay, so are you comfortable trying the synthetic division?
Yes. Okay, hold on. So you bring the 1 down.
Yes.
And then you multiply. So it'd be -2.
Yep. So where does -2 goes here?
Yeah.
Okay.
And then add that to be -11. Then you multiply again to be 22.
Wait a second. Okay, so I messed up here. I apologize.
That's okay. Is
I
it
apologize.
the wrong number?
No, so this is important. I wasn't paying enough attention. So see how there's a missing x cubed?
Oh
There's 0
yeah.
x cubed.
Yeah.
Yeah, and I was just thinking about other stuff besides this problem here, but you always have to have a descending number of exponents here. So x to the 4th,
Right.
x cubed, x squared, x, and that does change because I was looking ahead. I was saying, well, it's not going to work, and
Yeah.
you can see now that yeah, I mean that's a problem. So okay, so just confirm that you're okay with how I got those numbers. And this is an example of one where you have to try -2 again, because it's actually a double root. So I'd like you to try that. And
So how do you know what numbers to use like after you do the first set of synthetic division?
So you're trying these numbers. Anything in this list up here is fair to ask or to try.
Yeah.
Now, how does Matthew know? Matthew's graphing it in another screen, and I'm like looking for the zeros to know. And that's
Yeah.
the point I'm trying to make to you is like, if you don't have a way to know what the zeros are, you only can guess. And I don't know that that's fair, but that's where you're at in this course.
Yeah.
So go ahead and try this synthetic division here and see if you should get 0 here at the end when you're all done.
Yeah. I did.
You did. Okay. What are the other coefficients? Well, I can get them here. So 1, and then -2, -4, 8, 3. So you got, this is x squared minus 4x plus 3. And then what does that factor into?
Let me see. It would be -3 and -1.
So x minus 3, x minus 1. And then the other factors are x plus 2 and x plus 2, because those correspond to the -2 and -2.
So you have to always flip those signs.
Yes, exactly.
Okay. So what would the zeros would be negative or -2, -2, and then -3, -1.
You have to flip the sign. So it's +3 and +1.
Even for the zeros, you have to flip it.
Yeah. So okay. So the factors, let me show it to you differently. So let's just say x equals 3 is a factor. I'm sorry, is a solution. So if you subtract 3 from both sides, you get x minus 3 on the left equals 0. And if x equals 1 is a solution and you subtract 1 from both sides, you get x minus 1 equals 0. And if x equals -2, you're adding 2 to both sides to get x plus 2 equals 0. So what's inside parentheses is always opposite in sign to the actual solution.
Yeah. Okay.
So the solutions, the zeros over here on the left, they correspond to the opposite in sign.
Okay.
So let's keep going through this, because the more we do, the more it'll uncover the various little wrinkles, modifications that you'll need to know.
Yeah.
So, all right, so let's look at 13. All right, so we had the same number in the last problem, so it's no different, and there's a 1 there, so it's ±1, ±2, ±3, ±4, ±6, and ±12. So there's literally no way to know what number to try. Now you can do some things to sort of make a good guess, but there's really no way to know.
Yeah.
And I hate saying it that way. You just don't have enough knowledge to be able to do that. Now, if this were your test question, I would tell you to start with smaller numbers. And because everything is positive, do you see how everything is positive in here? You're going to need some negatives at some point. So I would go for negatives first, which, isn't really a great, it's like, I'd rather not, but that is the sort of limited on there on that.
Yeah.
Okay, so you might think to choose -1, and you bring your coefficients down, and this time we see 4, 3, 2, 1, 0 for the exponents. So we know we're good there. So go ahead and try this and let me know what you come up with for your last row.
Okay, I got 1, 3, 4, 12, and then 0.
Okay, perfect. And then we're going to try -3 now. Oh, okay, sorry. Before we do that, so -1 is a solution, but it corresponds to the factor of x plus 1.
Wait, so -1 is a solution. What does that mean? Like,
It means it's a zero.
okay.
0. 0 and solution mean the same thing. It also means x-intercept.
Okay.
All right, so the next one to try here is -3.
Okay, I got 1, 0, 4, 0.
Yeah, now this one's kind of interesting. You get your zero. This becomes x squared plus 4 in the last spot because it's really 0x in the middle, right? So it's really this 0 goes with 0x plus 4, but you don't write it. You just write x squared plus 4. But again, -3 is a solution, which means 0, which means x-intercept.
Yeah.
And that corresponds to x plus 3. Okay, now if you set x squared plus 4 equal to 0, and we did this in your last chapter unit, if you subtract 4 from both sides, you get x squared equals -4. We talked about how to solve this. We talked about there being complex roots if you take the square root of both sides. You probably want to ask your instructor if this is what you're expected to do. Because generally you would never write it with these as your solutions in factored form, but you might write it as a solution. So you wouldn't write this as a factor, this 2i, but you would write it as a solution.
Yeah.
That's where you may want to ask or look in the back of your book and see what it says. So in terms of your factored form now, okay, you actually go back to this line right here, this x squared plus 4. So you use that. And then we had x plus 1 and x plus 3. And this I would consider correct for your factored form.
Okay.
All right, so let's go to 15 next. All right, I want you to tell me all the factors of 16, please.
Okay, hold on, let me write this down.
Yep.
So it'll be 1, 2, 4, 8, and 16.
So 1, 2, 4, 8, and 16.
Yes.
Okay, and then I wish there was an example where there was a number in front here, like a 2 or something, but we haven't seen it yet. So
Yeah.
it gives you the impression that it's just these numbers, but really it's plus or minus all of these.
Yeah.
And again, yeah, it's a difficult conversation because you're a student, you got a teacher in the classroom, but you really want to ask them, say, hey, when I was working through these, I realized that it might be really hard for me to guess. You can say I'm a bad guesser, always guess wrong. So, what's my,
Yeah.
what do I do here? Because if you're not able to graph them, you're just not gonna see these. So there are a few other things you can do, like because there's some things with signage that you might have already learned, Descartes' rule of signs, but that doesn't help you that much. I mean, it's like it's useful, but you still would rather have the answer, and you're just sort of verifying it from here. So got this graphed again. Yeah. All right. So if you were to guess, what number might you guess out of this list? Anything jump out at you?
I'm so bad at guessing. I have to
Yeah.
like
So
look it
so, so
through.
let's just guess one, because I want you to see this,
Okay.
and I want you to see what happens. So you bring the one down, multiply, add 0, 0, -2, -2, -14, -14, and you get -30. So you know this is wrong.
Yeah.
Okay, so what do you do from here? Well, in for me, all I got to do is just clear this out. But for you, you gotta erase. You're basically starting over, and you got to also keep. Here's the thing: you also have to keep track of what you checked. You have to say, I checked 1 and it didn't work.
Mm-hmm.
So that's where it's frustrating. Now let's try 2. Okay, and
I think 2 works
looks
actually.
like 2 works. I also, have a so you know that 2 works. But again, like I mentioned before, you're actually supposed to try 2 again, because it could be a double root. And what I mean by that is like it could come down and touch there, and that would be a double root.
Yeah.
So, but it doesn't, so we're not going to try it. That is kind of what you're up against.
Yeah.
Okay. So go ahead and try -1 for me, please.
Okay. Yeah, that works.
What are the numbers down here in the bottom?
It is 14280.
Okay, so notice we were at an x to the 5th in the first line. When we reduced it by 1, that's x to the 4th. And now we're at an x cubed. We still need to keep guessing, because we have to get it down to an x squared before we can say for sure that it would work. So go ahead and try -4 for me, please.
Yeah, it's 1020.
Okay. Now we're down to a quadratic, so that the first one is an x squared, then an x, and then a non-x. So this becomes x squared plus 2.
Yeah, so we have to square root it again.
But whenever it's a plus a number, you're going to see that it doesn't work. So there is a solution to this one, but it's not real. And you probably want to ask, if that is, because it's x squared equals -2. You take a square root of both sides, it's plus or minus the square root of -2. That's plus or minus I square root 2.
Yeah.
And that is a solution. It's totally correct. But in terms of how you write it, you never write it with the complex, I terms. You just go back to the previous
Right.
form. So I won't ask you to do any of the other ones on your own, but you should be prepared to do this in, for a test or quiz. And, you have everything to be able to do it at this
Yeah,
point.
can we actually maybe just do one more of those just for practice?
Yes. Let me find one that's better, but I guess I can't. Let's just have you try 12.
Okay,
And do you want me to help you with the guessing, or do you want to try and guess a few on your own?
I can try and guess on my own.
Okay.
So the factors would be 1, 2, 4, 5, 10, and 20.
Yes.
So
And you'll just have to guess a few here until you get something.
so I can try 2.
Okay, so you're going to check 2. Make sure you keep track of the ones you check.
Yeah. Oh, it did work.
Okay, so you got 1, 2, 7, 14. Yeah. So the nice thing about this one, see how it's a cubic to start out?
Yeah.
By guessing 1, you're now down to x squared plus 7x plus 10. And this is also important that you remember that you don't keep trying synthetic division. You say, all right, let me factor this. Let me see if I can factor this. And you
Right.
can. 2 numbers that multiply to 10 but add up to 7.
Yeah. So it would be 5 and 2.
Yes. So this is important. There's 2 things you have to be able to tell me now. The zeros of this, and then the final factored form.
So it would be the zeros would be 2 and then 5 and 2. But would it be -5 and?
So you're really supposed to set those equal to 0.
Yeah, so it'd be -5 and -2.
Yes.
And then the factor form would be x plus 2, x plus 5, x plus 2.
They can't be the same, because if they're the same, that means there's duplicates in here, and there's not. So there's still some confusion about factored form versus the zeros.
Yeah.
And then I guess that'll get answered the next one, but it's, if 2 is a 0, that means x equals 2. And then you subtract 2 from both sides to get x minus 2 as your
Yeah.
factor. But the good news is you will see that in the next grouping of questions. You'll see that should get reconciled for you.
Yeah.
Okay, we're going to move to 22. Is that okay?
Yeah.
All right. Okay, so like what this list really means, this is what we've been talking about. It means x equals -2, x equals 1, and x equals 3. And these are the solutions.
Yeah.
And now what I've been trying to show you is that when you solve, not really solve, I'm sorry, when you sort of undo. So like when you add 2 to both sides, you get x plus 2. And this is the factor. In the middle one here, you subtract 1, and that gives you x minus 1 as your factor. Subtract 3, you get x minus 3 as your factor. Do you see the relationship between the factor and the solution? How x plus 2 is related to -2, x minus 1 is related to 1, x minus 3 is related to 3.
Yeah,
Okay, because that's got to be like super clear.
exactly.
Okay, now in terms of what you're doing here, it says write a polynomial function with a leading coefficient of 1 and the given zeros. You now have to multiply these factors together.
Yeah.
So you take the 2 that you like the most, which probably just be the first 2, and you're going to FOIL them. So could you do that for me?
Yes. So I got x squared minus x plus 2x minus 2.
Right, and you've got to be able to simplify that too. It's better if you can do it as you go. So this becomes x squared plus x minus 2.
Yeah.
Okay, now at this point, you may not know what to do, but you're just going to continue multiplying. And I'll use some different color here to sort of illustrate that. You're going to take this x and you're going to multiply it by each of these things. And you're going to take this -3 and multiply it by each of these things. But you could also look at it the other way. You could say, I don't like that. You could say, I'd prefer to look at it as I'm going to multiply everything in the left here by the right. So like x squared times x times 3.
Yeah.
And then, the x times each of these. They will give you the exact same result. And it really just comes down to like your preference. What do you like? So like sometimes in math, you get a choice. You get to decide, this is what I prefer. What does Isabel prefer?
Yeah. Probably the top one.
The top one. Okay. So let me just rewrite it here. So we're going to take that x and multiply it by each of these. You get x cubed plus x squared minus 2x. So as a reminder, when the bases are the same, you add the exponents.
Yeah.
Then you take the -3 and multiply it by everything here. Now, this is going to be a little bit different than what you've probably seen in the classroom. I like to line them up vertically. So see how
That's
it's
what he does too.
Oh, good. And the reason is it actually will be easier to reduce. It does take more space because you're going to add these up, but the end result is generally you get a better, more likely that you're correct in your answer.
Yeah.
Any questions on that?
No, I think is
Okay,
that
that's it.
the end of that?
That's the end of that one. This is your polynomial function. There's a little bit more of a, so sometimes the leading coefficient is not 1 and you have to calculate it from a given point, but they're not asking you to do that yet.
Yeah.
They're kind of like stepping you through this nicely. But 23 is more difficult. So we'll look at that. And if we have time, I'll have you come back and do like 21 on your own.
Yeah.
But we want to make sure we get through these two. There's also another type of problem here that they don't seem to have. So look at that. Okay, so the zeros are x equals 3 and x equals 4 plus I, okay? But the complex roots always come in pairs. So this 4 plus I is also paired up with 4 minus I.
Yeah.
Now, why don't they write it? I don't know. I mean, it's sort of like beyond my understanding. understanding. I mean, they expect you to know this. The rest assured, someone in your class will not write both of these on the test. Okay, so don't be
Yeah.
that person
Yeah.
if you can. Okay, so the only difference is the operator in the middle.
Yeah.
Okay, if this was -4, it would be -4. That's it. Okay, so just like we did previously, you're going to subtract or add stuff. So it's x minus 3. On the two on the right, you have two things to subtract or add. So it's x minus 4 minus I equals 0. And then on the right here, it's -4 plus I. So it's x minus 4 plus I. And those are your factors. So you have x minus 3 times x minus 4 minus I, x minus 4 plus I, like this. All right, now you should multiply the ones with I first. It's a lot easier if you do this.
Okay.
Okay, now if you do this correctly, and this is important, if you do this correctly, okay, all the I's disappear.
Because isn't I just 1 times it's
So,
like -1 times
well,
1.
I is the square root of -1, but
Yeah.
you're going to get I squared equals -1. You're going to have to use that also. But go ahead and let's just watch this. Watch this work its way out. So x times x is x squared. X times -4 is -4x. X times I is xi. Then -4 times x is -4x. -4 times -4 is 16. Now, notice I'm putting it in a different column because it doesn't match up with any of the others.
Right.
-4 times I is -4i. So I'm putting that somewhere else. Okay. And then we're going to now take this minus I times x. So you get minus xi or ix, the order doesn't matter. Minus I times -4 is plus 4i. Minus I times I is minus I squared. So when you add vertically, you're going to see that the xi cancels the minus xi, the minus 4i cancels with the positive 4i. And that should always happen. That's what I mean by the i's disappear.
Right.
And you're gonna notice your sum here at the end. It's x squared minus 8x plus 16 minus I squared. And you're supposed to be like, well, hey, Matthew, I thought all the i's cancel. Well, I squared is -1, so it's minus a -1. And like I just said, they all disappear because it goes away, it becomes a number. Okay, now you're not done, even though it feels like, wow, I've done a lot of work. I'm really, everything worked out the way you said, but you've got more to do.
Where did the x minus 3?
Yeah, and that's like you get so worked up, doing all this other stuff, and then you forget to bring down the thing. So from here, I'd like you to try multiplying this out,
Okay.
and let me know what you come up with when you're all done.
Okay. I got x cubed minus 8x squared plus 17x minus 3x squared plus 24x minus 51. Oh, did I get it wrong? I don't know if you're trying to talk, but I don't know if you're muted. I haven't heard a thing you've
Oh,
said.
I'm sorry. I'm sorry. So okay, let me back up. So I was trying to tell you that I hate when I do that. I was going to give you, 8 out of 10 on this because like you're really close. You're like 10% from the finish line. But
Yeah.
what it looks like you did not do is combine like terms.
Yeah.
And I'm guessing you did not write it in this kind of waterfall fashion. This is actually
No, yeah.
it's actually a waterfall. I don't know if you've ever seen one.
That's
Maybe
what, yeah, that's exactly what our teacher
yeah,
said.
and it looks kind of cool, but it's like you're so close to finish and you just didn't, it's like
I always forget to do the waterfall.
yeah, and what that'll do, actually that's 41x, not 51. What it'll, because you want to get these right. I mean, you spend all this time doing it. They're not hard, they're just a lot of work.
Yeah. Okay.
That's it for that one.
Yeah. I just need to remember to combine the terms.
Yes. All right, so pretty sure we have time here to finish 24. It is missing. What is the other factor that it is missing if it's 2 and 5 minus I?
So it should be positive I.
5 plus I.
Oh, 5 minus I. Yeah, yeah.
Yeah. So it goes like this. If they give you A minus BI, you also need to write A plus BI.
Mm-hmm.
And then there's just a lot of examples of this, but it's the same number, whatever that number is, you switch the minus to a plus. Now, sometimes they do give you a problem where it's just I or minus I, and you got to write I, but that is not the case here. So this is x equals 5 minus I, x equals 5 plus I. So you're gonna get everything on one side of the equation. So it's x minus 2, x minus 5 plus I, x minus 5 minus I.
Yeah.
So I'd like you to try the two factors on the right, multiply it out and see what you come up with.
Okay. There's like so many things to multiply. I like have to take it so slow.
Yeah, I'm gonna start working it out here. Just to make sure you've got you can see it here as well. But keep trying it out on your own. It really is good to do.
Okay, I got that.
Okay, perfect. So you're gonna notice here that the I terms cancel, except for that last one, that I squared. So you actually can put that in the column with the number if you want, but I sometimes leave it off to the side. It's really easy to mess up signs. Just really pay attention to that. So it ends up being x squared minus 10x plus 26. If you do enough of these, you will see a pattern to how to do it.
So
A shortcut, if you will. Go ahead.
if the both of the negative 5i, do you combine those?
Oh, one of them is supposed to be positive.
Oh, is it?
Yeah, that one's supposed to be positive.
Okay.
Because they have to go away. That's your check. That's your like, am I doing this right? Do they cancel? Yes. And then you're good. Okay, so let's we'll just finish this one up together because we're a little short on time here, but it's x cubed, x times x squared, minus 10x squared, x times the minus 10x plus 26x, and then 2 times x squared, 2 times minus 10x, 2 times 26, x cubed, minus 8x squared, plus 6x plus 52.
Yeah.
So if you have time, it'd be great to do some of these again. They're not short problems. You don't get a ton of these on tests. You get a couple of each.
Yeah.
We can talk a little bit more about that when you get closer to your test, but that one problem where we didn't put the 0 in, like the 0x cubed on 11, that's a test. That's a test question because that's the kind of thing they're wanting to check and see if you're looking out for.
Yeah.
All right, Isabel, well, that is it for tonight. Thank you for scheduling. I know we got another lesson coming up on Wednesday, so look forward to helping you then, and have a great couple of days.
Thank you. Bye.
You're welcome. Bye now.